We are going to discuss on the indirect intracoronal cast metal restoration. Okay. So here we're gonna discuss the introduction, definition, histological review, materials, its indication, contraindication, advantages, disadvantages, mouth preparation prior to the cast restoration, okay. And the basic concept regarding the cavity design, that is how much should be the taper for in-lay and on-lay, what is mean by circumferential tag in that bevels and depths. So what is restoration? So simply define the restoration as it can be defined as a material so placed in the prepared cavity of the tooth that its physiological and mechanical functions, anatomical forms, occlusion, contact points, and aesthetic appearance properly restored or preserved. And tooth in the area of restoration is protected as far as possible from recurrence of the dental caries. So what basically the restoration means is we have to remove the carious portion and we have to restore the tooth in its original form so that it will help for its main function, that is chewing, mastication, and phonetics. Right. So restoration we can divide it into two parts. The restoration can be a direct one or indirect one. Okay. So in direct restoration, we include that amalgam, glass enamel cement filling, composite restorations, and all other cements that we directly place in the prepared cavity. That is called as a direct restorative procedure. In direct restorative procedure, we prepare a cavity, then we place a direct restoration. But in case of indirect restoration, what we have to do? We have to prepare the cavity, then we have to take the impression, and we have to prepare the wax pattern for that. Okay. If in indirect restorations, there are also two types according to the wax pattern fabrication. You can directly fabricate the wax on the prepared cavity and invest it, or you have to take the impression first, then prepare a cast, then prepare a wax pattern on that, and do the cast. So generally, direct restoration is for the dental cements that we generally used in our clinic, and indirect restoration involves inlays, onlays, crown, veneers. So all these procedures are indirect restorative procedures. Okay. So materials used for the indirect intracoronal cast restorations are posterior tooth. Generally, for anterior, we used an aesthetic, that is ceramic only, right? But in case of posterior tooth, we can either use a metallic or a ceramic materials. So, according to the ADS specification number 5 for the dental casting gold alloys, requires a minimum total gold plus platinum metal content of 75% of it. Means for a casting alloy should possess more than 75% of gold and platinum. So at present, the alloys generally classified generally are used for, which are used for the cast restorations are traditional high gold alloys, low gold alloys, palladium silver alloy, nickel chromium alloys, and base metals alloy. So there are different classifications for the alloys. In 1984, ADA proposed a simple classification for the dental casting alloys. Okay? That is high noble metal, and predominantly base metals. High noble metals means which contain more than 40 weight percent of gold plus 60 weight percent of noble elements. In case of noble metal, it contains more than 25% of weight of the noble metal elements. And the predominantly base metal means here the noble metal content is very less, that is less than 25%. Marzuk give the another classification, right? The previous one is by the ADA. This is the first classification given for the dead customer. Again, Marzuk it divided it into the 5 class. Right. For class one, it is mainly consists of the gold and platinum group based dollar. There are they are again subdivided into type 1, type 2, type 3 gold dollars. Okay. Generally, we used class 1 for the preparation of inlays, onlays. In class 2, that is economy gold dollar or low gold salt. Here, the gold content is less than 50%. Or some may contain a very little amount of gold, that is 5%. The class 3 is non-gold palladium based alloy. Class 4, it is a nickel chromium based alloy. Class 5, it is a castable moldable ceramic. Okay. So what it has done, the idea again it's revised its original classification depending upon the composition of alloy. Right? It divided the cast gold alloy into 3 different types. That is A, B, C. Right? Here in A, the gold and platinum contains 83%, while the silver is 3 to 12%. That is, it is minimum in content. But in type 2, it is gold and platinum groups percentage is 78%, while the silver is 15%. Again, in C, there is a 78%, and other trace elements are 15%. So this specification was revised and extended to include the 4 types of alloy, that is 1, 2, 3, 4. Right? Type 1, type 2, type 3, they corresponds to previously ABC that you can see in this slide. ABC belongs to type 1, type 2 and type 3. So to increase the strength of the alloy, they incorporate type 4. Right? Type 4, what it contains? It contains 75% of gold and platinum, then 60 to 70%. Then copper is incorporated into this, that is 11 to 16%. Then rest are the stress elements, right? Platinum, palladium, and zinc. So here you can see silver, gold, silver, copper, platinum, palladium, and zinc. These are main compositions. So now we will discuss the function of each component. The gold, it is primarily responsible for the deformability, strength, and characteristics yellow color of the castings, right? And also the density. So as we all know, gold is a very noble metal. It doesn't react with any other metal. So it reduces the tarnish and corrosion. Also provide the ductility and malleability. What is ductility and malleability? It is ability of the metal to form sheets and ropes. So gold is the metal which is having highest malleability and the ductility. So the second element is copper. It is the basic element which gives the strength for the alloy. That is, it is a principal hardener. It reduces the melting point and density of the gold. Right. Also, it helps at the edge hardened of the gold alloys. So in greater amount, if you use the copper in a greater amount, it reduces the resistance to the tarnish and corrosion. Copper, it easily get eroded, right? It is more prone to tarnish and corrosion. So it should not be exceed more than 60%. What happens if we extend this it to more than 60%? There will be more tarnish and corrosion will take place. So again, there may be a marginal defect will produced, and your casting will there will be failure in your casting. So, generally, what is the other function of this copper? It is, as you all know, it is a reddish in color. So, it gives this texture of red color to the castings. So, to counteract this, we have to add a silver. So, what does the silver does? It whitens the alloy, thus help in the counteracting the reddish color of copper. And in slight extent, it increases the strength and hardness. Also, like the copper, silver also reduces the resistance to tarnish and corrosion. The next one is platinum. So platinum is basic for the strength. Alloy of the strength, alloy strength is come from this platinum. And the second important feature of this platinum is it is corrosion resistance. Then it also increases the melting point and whitening effect on the alloy. So we have to increase the melting points of the alloy at some extent to form a homogeneous mixture. So platinum perform the same function. Also, due to the platinum, we can reduce the grain size. Palladium is having the same similar effect as that platinum. It hardens as well as whitens the alloy, also raises the fusion temperature and tarnish uh, tarnish resistance. Uh, and it is why it is generally used, because platinum is, as we all know, it's a very expensive material, right? Metal. So the palladium is a cheaper version of it. So generally platinum is replacing the palladium. So then last is zinc. Zinc, it acts as a scavenger for the oxygen. What is meant by scavenger? Scavenger means here zinc is readily undergo oxidation and prevent the oxidation of other elements. Right? So without zinc, the silver alloy causes the absorption of oxygen during the melting. It is same what you see in the amalgam, right? There also zinc acts as a scavenger. Here in cast metal also it acts as a scavenger. Right? Later during solidification of the oxygen, uh, later during the solidification, the oxygen is rejected, producing a gas porosities in the cast. So what basically happened if amalgam absorb the silver alloy absorb the this oxygen, or it readily undergoes the oxidation. So it during a melting stage it undergo oxidation, and while there is a solidification, then this oxygen gas is released. Okay. So there is a gas hole porosity is seen in this casting. In minor other ingredients which are present are indium, tin, iron, gallium, iridium, ruthenium, and germanium. So now we come towards the physical properties of all these materials. Right. So class 1, class 2, class 3, class 4. Right. For the class 1, the density is 15 to 16. The melting range of this class 1 alloy is 1800 to 2000 Fahrenheit. Tensile strength is 80,000 Fahrenheit, while the yield strength is 40,000 Fahrenheit.
More.
More.
हे खाली पिंबल दिसायत का फाईलच्या बाजूला तीन सेव्ह चॅट कट करा ते
Okay. Now we'll basically compare the physical and mechanical property. That is, for the class 1 alloy, the density should be 15 to 16. Melting range is 1800 to 200. 1800 to 2000 Fahrenheit. Tensile strength is 80,000 psi. Yield strength is 40,000 psi. So in class 2, again the density is 11 to 12. Melting range is 20 to 100 Fahrenheit. Tensile strength is 1 lakh psi, and yield strength is 47,000 psi. Okay. In class 3, the density is 10 to 11. Melting range is 2250. Tensile strength is 1 lakh 40,000. Yield strength is 65. Class 4, it is density is 8. Melting range is 3500. Tensile strength is 1 lakh 60,000, and yield strength is 80,000. So when you prepare this as a chart, it will be very easy to remember, right? So here the density is going on decreasing from class 1 to class 5, while the melting ranges goes on increasing from class 1 to class 4, right? And also the tensile strength is increasing from 80,000 to 1 lakh 60,000. Next one is, so again, the class 1, there is a more elongation is there. Uh, that is 20 to 25%. In class 2 also there is a, in class 2 also there is also 20%. In class 3, 15 to 18%. In class 4, 3 to 11%. So the hardness 150 to 70, 200, 250, 315. So the most important is tarnish and corrosion. In class 1, there is absolute no tarnish and corrosion as the gold content is high. But in a class 2, there is 2 to 3 percentage of uh, corrosion, tarnish and corrosion. In class 3, 5 to 10% of tarnish and corrosion. And in class 4, there is 0% of tarnish and corrosion. So, now we will describe in short the different properties of the alloys. The class 1 is high noble alloy, right? It is again divided into 4 types. So it is type 1 is soft, that is its hardness is 60 to 90 VHL. Type 2 is medium, it is 90 to 120. Then type 3 is hard, it is 120 to 150. Type 4 is extra hard, that is uh, more than 150. So there is a typing error, it is more than 150. So the type 1, most plastic, what is this? It is a very plastic and highest gold content. So that's why it is a soft. Type 2 and type 3, they are used for the single tooth restoration. While type 4 is least deformable with less content of gold. So from this you can see that if the gold content is more, then the material is going to be very soft. Right? As the gold content is decreased, the hardness also increases. Sorry, somebody is cutting the mic or what? Hello? So now in class 2, there is gold is less compared to the class 1 alloy. Palladium is usually used as a gold substitute. So some alloy may contain 60% of palladium and as little as gold. Copper result in the strengthening and the hardening effect. Like as I already told you, the class 3 and class 4, they are basic nickel and chromium combinations. So generally the base metal casting alloys are nickel chromium. Then nickel chromium we are again classified into with beryllium or without beryllium. And then next is cobalt chromium and titanium alloys. So in the next lecture, we will cover the indications of intracoronal cast metal restoration, uh, advantages, disadvantages, contraindications, and mouth preparation for this cast restoration. Right. Its metallurgy part is like boring. You have to just keep in mind that generally the cast alloy are basically divided into class 1, 2, 3, and 4. The class 1 is again divided into 4 types, that is type 1, type 2, type 3, type 4. In that, generally the most commonly used gold alloys in the dentistry are class 1 and class 2. Sorry, cast alloys are class 1 and class 2. So in the next lecture, we will discuss it. Again, the indications, contraindications, advantages, and disadvantages.